Thriving Academy. In today's class, we'll be looking at the derivation of the diffusivity equation for a radii flow. Derivation of the diffusivity equation for a radii flow. So, for us to derive the radii flow diffusivity equation, first of all, we have to recall the continuity equation that we got from radii flow, which is 1 over rho d rho v divided by d rho equal to d phi rho divided by dt. Now, in this equation, if you look at this equation, we have v here. So, that v simplify the volumetric flow velocity. We equate the v as 2.637 times 10 raised to the power minus 4 k all over mu dp all over the rho. So for us to derive the diffusivity equation for radii flow, we have to substitute this v here into this particular formula, so that anywhere we see v in this formula, we are going to replace it with this whole equation. So if we do that, we are going to have 1 all over rho d all over the rho into, if you look at this is rho rho v, so we are going to have rho rho v. Now in place of v there now, we said that v is equal to d, so we are going to substitute this particular formula in place of v, which is 2.637 times 10 raised to the power of minus 4 k all over mu dp divided by the rho. Close this bracket, which is this, then close this second bracket, which is this. Now, since we have substituted v, formula is equal to d phi rho all over dt. So let's write it out. D phi rho divided by dt. So we have this. If you look at this critically, you find out that this particular value here is a constant, k, and mu here is also a constant. So we are going to bring this value and k all over mu out of this particular bracket. We are going to bring it out of this bracket. So if we bring it out of the bracket, we are going to have 2.637 times 10 raised to the power of minus 4 k divided by mu. Now this one, I will say that this is the constant, so we'll bring the constant out of the bracket. Then we are going to have 1 all over rho here, which is 1 divided by rho, then multiply by this now, which is d rho into rho, which is this, density, which is this. Then remember that we have already removed this constant out, which is this. So we are only left with what? dp all over the rho. So we are left with dp divided by the rho. So close this bracket, then is equal to partial phi density divided by dt. So we have this equation. We have this equation. So let's solve. Let's divide through by this value. Divide through by this constant, which is from here to here. If we divide through by this constant, we are going to have 1 all over rho d all over the rho into rho rho dp divided by the rho is equal to, remember that we divide through by this particular constant. So since we divide through, and this other side, it will become the inverse of this. So we are going to have mu all over 2.637 times 10 raised to the power of minus 4 k. Now this particular one now is gotten when we divide through by this, we have the inverse of this, then multiply by the phi rho divided by dt. So we have this. Since we have this, the next step now is to differentiate what we have in this bracket. Differentiate what we have in this bracket. For us to differentiate what we have here, we have to differentiate this one, differentiate this with respect to arrow, differentiate density with respect to arrow, and also differentiate dp over the arrow with respect to arrow. If we do that, we are going to have, first of all, let's take this one out first. We are going to have 1 over arrow into. Now, let's differentiate arrow with respect to this. Remember, from your partial derivative, if you are differentiating more than one variable, if you are differentiating this one, the rest one becomes what? Constant. So if we use that particular method, if we differentiate arrow, we are going to have the arrow all over what? The arrow. Then rho and this one here becomes what? Constant. So here becomes rho dp divided by what? The arrow. Remember, we differentiated arrow. If you differentiate this one, these two becomes constant. So since we have differentiated arrow and these two becomes constant, the next step is to differentiate density. If you are differentiating density, arrow and dp over the arrow becomes what? Constant. So this will give us plus arrow dp all over the arrow. Then differentiate density now with respect to arrow. We are going to have what? Dot the rho all over what? The arrow. So we are done differentiating density. Next step now is to differentiate dp over the arrow with respect to what? The arrow. So if we are differentiating this one with respect to the arrow here, we are going to have what? Plus, we are differentiating this one. So arrow and density here becomes constant. So if they are constant, here we are going to have arrow rho, which are the constant. Differentiate this one now, we are going to have what? You know, this one is already derivative. So if we are differentiating a derivative with respect to this one here will become what? The square. The here becomes what? Square. If that is the case, here we are going to have what? The square p divided by what? The arrow square. So if we differentiate this one with respect to this, we are going to have this. Then let's close this bracket, which is this, then equal to mu divided by 2.637 times 10 raised to the power of minus 4k. The same way we differentiated this other side, we are still going to differentiate what? Porosity and density the same way. So if I have to do that, we are going to have differentiate porosity. If you are differentiating porosity, density becomes what? Constant. So we are going to have density. Differentiate porosity with respect to dt. Now we are going to have what? The porosity divided by what? Dt. Also, since we are done differentiating this one, differentiate what? Density with respect to what? T. If you are differentiating density, this one here becomes what? Constant. So this becomes plus phi becomes constant. Differentiate this one with respect to this. We are going to have what? The density divided by what? Dt. So we have this. This 1 over arrow is multiplying everything you have in this bracket. If that is the case, let's use this 1 over arrow now to open the bracket. If you use 1 over arrow to open this bracket, remember that the arrow over the arrow will cancel out to give us what? 1. 1 times everything here will give us what? Just what we have here. So 1 all over arrow times everything here, we are going to have what? So let's open the bracket, this bracket with 1 all over arrow. If we do that, we say that the arrow over the arrow will cancel out. Then 1 all over arrow times rho dp the arrow, we are going to have rho all over arrow dp all over the arrow. Then 1 all over arrow times arrow dp the arrow dot the rho the arrow, we are going to have plus arrow divided by arrow dp all over the arrow dot the rho divided by the arrow. 1 all over arrow times arrow rho the square p over the arrow square. We are going to have plus arrow all over arrow rho the square p divided by the arrow square. This will be equal to mu divided by 2.637 multiplied by 10 raised to the power of minus 4k into rho d phi divided by dt plus phi dp divided by dt. We are going to have this. So let's cancel out. If we are to cancel out, here there's nothing can cancel out here. So we'll be left with rho divided by arrow dp divided by the arrow. Arrow will cancel arrow here. We'll be left with plus dp divided by the arrow dot the rho all over the arrow plus arrow will cancel out here. We'll be left with rho the square p divided by the arrow square equal to mu divided by 2.637 times 10 raised to the power of minus 4k into rho d phi divided by dt plus phi dp divided by dt. We are going to have this. Remember, at this point now, all the same terms, all the terms have cancelled, all the arrow terms have cancelled, and this one will cancel this also cancel this. So if that happens, we are going to have this equation. So if we have this equation, the next step now is to divide through by density. Divide through by density, which is rho. If you divide this first equation by density, density will what? Will cancel out. So divide everything here by density. So if you do that, divide this first term by density, density will what? Will cancel out. If density cancels out, we'll be left with what? 1 all over what? Arrow dp all over the arrow. Remember, we'll divide this one here. We'll divide this by what? Density. Divide this by density. Divide this by density. Divide everything here by what? Density. So the first one now, density cancels this density. We'll just be left with what? 1 all over arrow dp the arrow plus, there's no density here. So if density divide this one, we're going to have what? 1 all over rho dp divided by the arrow dot the rho divided by what? The arrow. The next step now, density is here, so density, I cancel density, will be left with what? The square p divided by the arrow square. Then, if you look at this, there's no density, so we can simply rewrite this density as, this will give us mu divided by 2.637 times 10 raised to the power of minus 4k. Since we are dividing it by density, we can simply rewrite it as what? 1 all over what? Density into what? Density d phi over dt plus phi dp all over what? Dt. The rho all over dt. This is supposed to be rho and not p. The rho dt. Since we have this, the next step from here now is somewhat complicated, but from this point, we apply chain rule to dp all over the arrow here. Then we also apply chain rule to the phi all over dt. We also apply chain rule to the rho all over what? Dt. So from here we apply chain rule. So apply chain rule to the rho all over the arrow, the phi all over dt, and the rho all over what? Dt. So first of all, let's apply chain rule to the rho all over the arrow. If you apply chain rule to the rho all over the arrow, then we will simply have the rho divided by the arrow. In chain rule, you can simply write the rho divided by the arrow as the rho divided by dp dot dp divided by what? The arrow. In such a way that dp will be able to cancel out what? Dp. If dp cancel out dp, you are going to have what? The rho divided by what? The arrow, which is the same thing as what we have here. The same thing we did here. Let's do the same chain rule to define all over dt. If we do that, we are going to have the phi over dt here will be equal to what? The phi divided by what? Dp multiplied by dp divided by what? Dt. Such that dp cancel out, we will be left with what? The phi dt, which is the same thing here. Also, applying chain rule to the rho dt, the rho all over dt, we are going to have the rho divided by dp multiplied by dp divided by dt. So that this one can cancel this one, we also left with what? The rho all over. So the next step now is to substitute in place of the rho over the arrow. We are going to substitute this equation that we got from chain rule. In place of the phi dt, which is this point, we are going to substitute this equation we got from chain rule. In place of the rho dt, we are going to substitute this equation we got from chain rule. So if we do that, we are going to have 1 all over arrow dp the arrow plus 1 all over rho dp all over the arrow. Now if you look at this point here, we have what? The rho the arrow. What is like the rho the arrow? So that from chain rule, the rho the arrow is equal to the rho dp dot what? Dp all over the arrow. So we are going to write the rho dp dot dp the arrow. So this one here now represents what? The rho the arrow. Then plus the square p divided by the arrow square. We are done with this other side. So let's go to the right hand side. Right hand side, going to have rho divided by 2.637 times 10 raised to the power of minus 4k, which is this, multiplied by 1 all over rho into, now here we have rho. We said that in place of the phi dt, we are going to substitute what? The phi dp and dt. So here we are going to have the phi all over dp dot dp all over dt. Now this one, and these two things simplify the rho dt, so that this one cancels out. We also have the rho dt. Then in place of the rho dt also, we are still going to substitute this one here. So in place of the rho dt, we substitute what? The rho dt is equal to this one chain, so I want to substitute this equation. So this will give us plus the rho all over dp dot dp divided by what? Dt. So we are going to have this equation. The next step now is to, since this one here is the p the arrow, and we also have the p the arrow here, they are multiplying. So just write them out at this left hand side. Then when you come to the right hand side, you have rho here and you have phi here. all you have to do at this other side is to factor out rho and what? Phi. So to factor out rho and phi, let's write out our new equation. We are going to have 1 over r dp dr plus 1 over rho. Remember what I said? I said that since this one is dp dr, this is dp dr, we can simply write it as dp all over dr all the what? Square, right? Multiply by what? The rho over what? dp. Then plus the square p divided by the r square. This will be equal to mu divided by 2.637 times 10 raised to the power of minus 4k into 1 all over rho, close brackets. Now I said that we are going to factor out what? Rho and what? Phi. If you think that this is the same thing as rho and phi, we factor out these two. So if you factor out rho phi from this first equation, what are we going to have? If you factor out rho phi from this first one, what are you going to have? Factor out phi, there will be no phi here. Then also, factor, there is no rho here. So if you factor out rho, you are going to have factor out rho here, there will be no rho here. Then, if you look at this, there is no phi. So if you factor out phi, you are going to have what? 1 over what? Phi. So that if this one multiply this one over phi, you're still going to have what? 1. Just like when there is no phi. So we're going to have 1 over phi into what? The phi divided by what? dp. Dot what? dp divided by dt plus, if you factor out rho, factor out phi from here, there will be no phi, is out. Factor out rho from here, there is no rho here. So if you factor out rho from here, there is no rho, we are going to have plus 1 over what? Rho into the rho dp plus dp dt. So let's close this. This bracket closes at this point. We are going to have this equation. If that is the case, remember that 1 over rho is multiplying this one, multiplying this one. So if that is the case, you can simply say that, okay, this 1 over rho is multiplying what? This one here. And simply say this one is multiplying this one and also multiplying this one. And also, instead of, since everything here is addition, you can simply write this one first, then plus this before this one. It's still the same, just that we are just rewriting it and changing the word, the order. So if we do that, we are going to have 1 over r dp dr plus, instead of writing this one first, let's what? Write this one. So we are going to have plus the square p divided by the r square. Then plus, now we just wrote this one, which is this. Now let's write this one. Now this one, we can simply write it as plus 1 over what? Rho, which is this. Remember, it's multiplication. This one is multiplying this one, multiplying this one. You can also write it as this one here, multiplying this one, and then what? Multiplying this one. It's still the same thing. So this is 1 over rho dot the rho over dp dot what? dp divided by the r, all the what? Square. So it's just this the same thing that we have here, just that we change the arrangement. Then this is equal to mu divided by 2.637 times 10 raised to the power of minus 4k. Now if you look at this is 1 over rho. 1 over rho times rho phi. You see that rho here, you cancel this rho. So we left with what? Phi. That is multiplied by phi into, if you look at this bracket from here to here, something is common. What is common? The PDT is common, this point here, it's also here at this point. So you can still see that the PDT is common for this first one and what? This second one. So we factor the PDT out. So let's put dp at the ending. Let's factor it out at the ending. So if we factor dp out, we're going to have 1 over 5 into dy over dp plus 1 over rho over dp. Close the bracket. Remember that we factor out what? dp dt. So here we are going to have dp dt. So we have this total compressibility equation. Recall that total compressibility equation CT is equal to C plus CF, where CF is equal to 1 all over 5 divided all over dp, and C is equal to 1 over rho divided by dp. So anywhere you see 1 over 5 divided dp, you substitute what? In CF. And anywhere you see 1 over rho dp, you substitute what? C. If that is the case, you can simply rewrite this equation as 1 over rho dp dr plus d square p divided by the arrow square plus. Now if you look at this point now, we have 1 over rho times what? The rho dp, which is the same thing as what? C here. So since we have 1 over rho the rho dp, you can simply, instead of writing this whole equation, you can simply write what? C. If we do that, this will give us what? C times what? dp all over the arrow square. This will be equal to mu divided by 2.637 times 10 raised to the power of minus 4k. Now remember that there is phi here. Phi is multiplying this constant too. So we can simply say that this is the same thing as what? Mu phi. So into, if you look at this bracket, we have 1 over 5 divided dp. And we said that 1 over 5 divided dp is our what? CF. So instead of writing 1 over 5 divided dp, you can simply write what? CF. So here we are going to have what? CF plus. Look at this point, you have 1 over rho dp. And we said that 1 over rho dp is our what? C. So we can simply substitute C in place of 1 over rho dp. So this will give us what? C. Close this bracket, and we are going to have dp divided by. We have this. You can simply write this. Since we have this, let's assume that, assuming dp all over dt all is square equal to 0. Assuming dp dt square is equal to 0, what will become this equation? This our equation will become 1 all over arrow dp all over the arrow plus d square p divided by the arrow square plus. Now we said that this one is 0. So if this one is 0, 0 square is what? 0. 0 times c will give us what? 0. So everything here becomes 0. This will be equal to mu phi divided by 2.637 times 10 raised to the power of minus 4k. Into, remember now, if you see this, you have CF plus what? C. If you come here, we said that CT is equal to what? C plus CF, which is the same thing as what? CF plus C. If CF plus C is the same thing as C plus CF, which is also equal to CT, you can simply say that this thing here is the same thing as what? CT. So you can simply say that this is multiplied by what? CT. Then times what? dp all over what? dt. So we have this. So from here now, let's factor out 1 over arrow from these two equations. Let's factor out 1 over r from these two equations. If we factor out 1 over r, we are going to have dp divided by the r. There's no 1 over r there. Plus, if you look at this now, there's no 1 over r here. So if you factor out 1 over r, we are going to have r the square p divided by the r square. So that 1 over r multiplied by r will still give us the square p over what? The r square. Equal to, remember everything here is multiplying what? Ct. So you can simply say that this is equal to mu phi ct divided by 2.637 times 10 to the power of minus 4k dp divided by dt. So the next step now, since we have this kind of expression, we can express what we have in this bracket in terms of product rule. How do you express this in terms of product rule? To express this in terms of product rule, you can simply say that this is the same thing as d divided by the arrow of, remember, if we take this one and this one, if we take this one, if we take this one and this, if we take this one and we take this one and this one here, right? We take this one and differentiate it, we are going to go back to this expression. So, instead of writing this whole thing, I simply express this in terms of product rule as arrow dp divided by the arrow, so that if you differentiate this term in terms of product rule, you are still going to have this particular equation. So this now will be equal to mu phi ct divided by 2.637 times 10 raised to the power of minus 4k dot dp dt. So this particular equation is the diffusivity equation for radial fluid for slightly compressible fluid. So this is the diffusivity equation for radial fluid for slightly compressible fluid. Thank you.